Okay, now that we've got the phone set up so that it's projecting a Wi-Fi signal and we can program it, we're going to code the robot from a laptop computer. So what you'll do is you'll go to your network settings, and in your network settings, if you refresh it, you might need to unplug and replug the phone for it to actually refresh, but you should eventually see a Wi-Fi signal coming from your phone. It's called Direct 1S, there's your team number, and then there's RC for robot controller. It will be limited, so you can't access the internet while you're connected to the phone, but you can program the robot. Once you're connected, you open up a Chrome browser, and you're going to go to the address bar. Notice it's not the search bar, it's the address bar up here, and type in the IP address that shows up on your phone's screen. So mine starts with 192, and then it's in my history already, so I'll just hit enter. And if you've done it right, you'll see a screen that looks an awful lot like what's already on your phone. Then you can click the link that says OnBot Java, and you'll get to the Java programming interface. You can actually program in Java from your phone. It's just annoying to type in Java code from a phone screen, so it's a lot easier to do it from a laptop. In this Project Explorer, if you look on the left, there's a set of folders, and just notice the team code folder. That's where all of your code is going to be located. If you don't see it, just click this little triangle to expand it. We're going to add a file to do a driver-controlled mode. And the driver-controlled mode will be pretty simple. All we'll do is we're going to write some code to make the left joystick drive the robot forward and backward when we push the joystick up and down. We'll use the right joystick for turning if we move it side to side. And then we'll use one of these buttons on the front. I'm going to choose the right trigger as the button that will control the servo. So that's what the code will do. So what we do is we're going to use this plus button to add a new file, and you'll get this file browser window. Type in a file name that you can remember, so I'll call this maybe gamepad simple. So it just controls the robot simply from a gamepad. Make sure you choose the location and it's set to be team code. So you can use the file browser down here to select the folder that says team code, and then you should see that populated here. That's really important. Next, you can base this off of a sample. We're going to choose the most basic sample that we can find and just create the code from scratch so you understand what the code does. So I'll pull down this window, and I'm going to choose a blank linear op mode. Blank linear op mode, and it looks like it wants to open up a different browser, so let's just go back to the desktop. Awesome. Okay, blank linear op mode right there. Next, choose teleop. Teleop is driver controlled. Autonomous is obviously autonomous. And then the last checkbox I recommend is that you click Setup Code for Configured Hardware. This will read the configuration file on your phone and import that hardware into your code already, so that way you don't need to remember what you named everything and type those things in from scratch. Click OK. Okay, and then here we show up with our new file. So let's just talk about a few programming structures to begin with. There's a few different sections that are really important in here. One thing to notice is that some of the code shows up as this green color. And if it's green like that, it's a comment. That's not actually code. They're just like notes to yourself, and they're completely ignored by the programming language. Comments are denoted two ways. One way is you can put // at the beginning of a comment section, and then /* at the end, and anything in between // and / will be ignored by the coding language. The other way is just to comment out one line at a time by putting 2 slashes in front of that line. So if I typed in something that says, note, ignore this line, you can see it shows up with a red X because this is not a valid line of code, but I want to ignore it anyway, so I just put 2 slashes in front of that line, and now notice it turns green and it's a comment. So this is one way that you can kind of take lines of code out of your program, is just to comment it out by putting 2 slashes in front of it. I don't want that there at all, so it's going away. In the next section, we have a section of libraries. So before any of the coding commands come in, you can import code that somebody else has already written that you want to use in your program. So in this example, we've imported a library for linear op mode. We've imported a library for servo. This is going to come in handy as we have to control the servo motor. We're importing code for a gyroscope, which I didn't even know we had, but apparently we do. And there's many other libraries included. DC motor is the other really important one that we'll use to program our robot. So you don't need to do anything with these lines. They're just libraries someone else has written that we're going to be using in our code. Scrolling down, you can see there's another comment section. And then just to give you a bird's eye view of what the whole thing does, in Java, Java is an object-oriented language, so all of the coding statements are located inside classes. And a class contains data, and it also contains behavior. The data are called properties, and the behaviors are called methods. So since all of our code has to be enclosed inside a class, here is a public class, and it has the same name as the file, Gamepad Simple. You can see this is called a curly brace. It looks like a little sideways mustache. You make these punctuation marks by hitting Shift and then the square bracket, which is like above the Enter key. These curly braces enclose multiple lines of code. So everywhere you see an open curly brace, there has to be a matching closed curly brace that encloses a section of code. This is the beginning of the class. All the behaviors that work for this op mode are enclosed within a set of curly braces started here. Most of the time, if somebody's a polite coder, they'll indent such that like matching sets of curly braces are indented the same. So where this line is indented all the way at the end, if I arrow down, I can see a matching curly brace at the same indent level. So the curly brace at the top and then this curly brace enclose all of the code for that op mode. That's everything. So all of your code has to be inside those. Inside this class, these are your data members. These are your properties. So the information we're going to be using in this class includes the hardware definition for the claw, or servo motor, a hardware definition for a gyroscope, which again, I didn't even know we had, but apparently our phone has defined in it somewhere. And we have two DC motors, left and right. From now on in the code, the DC motor on the left is just known by the name left, and the DC motor on the right is known by the name right. And our servo motor will henceforth be known as the claw, just claw, all lowercase. Next, we get to this section that says run op mode, and this is a behavior. So inside the class, this is the behavior that runs when you actually start the op mode. So all of the code that's going to actually do stuff is enclosed within this set of curly braces. Here's the open curly brace, and then politely at the same indent level, this is the closed curly brace that encloses all of the code for this op mode. Okay? Notice also that every command, every programming statement ends in a semicolon. So it's really important to include that punctuation. Last thing, about structure, Java is a case-sensitive language. So it sees uppercase and lowercase letters as completely distinct characters. When we type in the command hardwaremap.get, hardware map spelled with a capital M and hardware map spelled with a lowercase m, they're different from each other. Hardware map with a lowercase n isn't something that the computer knows how to do right now. It only knows how to manage hardware map with a capital M. So really pay attention to spelling and punctuation as you go through the programming language. Copy and paste if you need to. If you run into errors like it says unknown symbol or symbol not defined, you probably have a spelling or capitalization problem somewhere. So before we start coding it, I just want to notice up here there's a line that says @teleop, and this is just an attribute of the code. It's not actually a command. I'm going to give this a name so that that name will show up in the driver station phone when I run the program. So the name that I want to show up is Gamepad Drive. And I'm making it no spaces inside those quotes. Oh, sorry, I forgot one important thing, name equals. So after the word @teleop, we do an open parentheses. This is just curved, it's not a curly brace. Name equals, and then enclosed within double quotes, we put in the name of the program. So this is what will show up on here after we build the program. Okay, let's get into actually coding this thing then. So I'm going to go inside the class, and inside the class, I'm going to go inside the code for run op mode. Now this run op mode has two sections. First is what happens after you hit the run button, but before you hit after you hit init, but before you hit the play triangle, and then after you hit the play triangle. So anything that happens before wait for start is what happens when you hit init. And then when you hit the play triangle, it'll start running the code after wait for start. So everything above line 63 is what happens when you hit init. Everything after line 63 is what happens when you hit play. So for init, all I really want to do is two things. I want to set my servo in its initial position, and I want to configure my motors so they're running in the correct direction. I mentioned before that my motors are opposite each other. So forward for one of them is forward, and forward for the other one of them is actually reverse. So I need to configure my motors to run in opposite directions. I've done a little experimenting with mine already, and I know that my left motor has to run in reverse, and my right motor has to run forward. If you haven't done this test with your motors already, just pick a direction, try it, and if your motors run opposite of what they're supposed to, change it and then rebuild. So we'll do left, because that's the name of the left motor as it's specified here. The dot operator dives into that object and can find the behaviors of it. And if I start typing, like for example, set, I get set direction. Okay, and we're going to set the direction of that motor to be DC motor with a lowercase c dot, let me make sure I've got this correct here. DC motor dot, I believe it's direction, yes, dot reverse, and reverse is all caps. Notice I've put the DC motor dot direction dot reverse inside parentheses, and I've ended that statement with a semicolon. Next, we'll do the same thing for the right motor. Right dot set direction, parentheses, capital D, lowercase c, motor with a capital N, dot direction with a capital D, dot forward, all caps. Okay, and then lastly, we're going to set our servo to just be in its initial position. Now, I'm going to hold up my servo motor so you can kind of see. The servo motors, they're not super powerful. They don't have a ton of torque unless you get special high torque servos. So just count on them to do small things like operate a claw or like a sweeper arm or something like that. This claw in this example, I want it to start in the up position and then move down to about 90 degrees when I push the trigger. These servos go 180 degrees, and the way this is mapped in the software is that one end pegged all the way one way is 0, and then pegged all the way the other way is 1. So at 90 degrees, that's 0.5 because it's halfway between 0 and 1. I don't know for sure at first whether my servo is going to be starting at 0 or 180, or sorry, 0 at 1 or 1. So I'm just going to make a guess and then make sure I really watch my robot carefully when it sets up, and if the arm goes in the wrong direction, I'll stop the code, program it to the correct setting, and then rerun it. So I'm just going to take a guess that this is 0, and halfway, that's always going to be 0.5. So let's start off with the servo, which is named claw dot sets position, and we'll set the position to be 0.0. Okay, so this is everything that happens when you hit init. It's just going to set the directions of the motors, and then it's going to set the position of the claw to be in its starting position. Next, we're going to wait until you push the triangle, the play button, and when you hit the play button, we enter into this section of code. Again, here's some commands that are enclosed with curly braces. This section of code says while, and then inside these parentheses, there's a true or false condition. The true or false condition is op mode is active. As long as this is true, it's going to run the code inside the curly braces over and over and over again. So right now, all it's doing is doing telemetry data. Telemetry data are these little messages that show up at the bottom of the phone screen when you're running a program. So it's going to be saying status running, status running, status running over and over again. But you can use telemetry to show important information about what's going on in your program if you would like to send those kinds of messages to your phone. What we're going to do is we're going to read information from the gamepad and then respond to that information by making the motors move. So inside this curly brace and that curly brace right there, notice again the indent level is the same as here. We're going to add some code that's going to check the gamepad, and then based on what it reads from the gamepad, it's going to set the motors. So I'm going to make a couple of variables, double left y and double right x. So the left y is the value that comes from the left joystick's y-axis, up or down. Right x will be the value that comes from the right joystick's x-axis, side to side. Okay. The y-axis on the gamepad is going to be a value between -1 and +1. Now you would think that when you push it all the way up, you get a +1, and when you push it all the way down, you get a -1. However, it's just the opposite. Up gets you a value of -1, and down gets you a value of +1. I'm not totally sure why it's opposite of what you would guess, but it is. The x-axis, however, is exactly as you'd expect. Going to the right is +1, going to the left is -1. So this is important to know as we read those values. So I'm going to make it so that the Y joystick will make the motors go forward or backward. What we'll do is we'll say left Y is equal to gamepad 1. If you only have one gamepad, it's gamepad 1. If you have two gamepads, then you'll have gamepad 1 and gamepad 2. So gamepad 1 dot left. Notice when you start typing in left, you get all kinds of tooltips here, and we want the left stick Y. But since left stick Y is negative if it's up and positive if it's down, I want to reverse the sign of that. So I can do that by simply multiplying it by -1. Because if you multiply a negative times a negative, it becomes a positive. And if you multiply a negative times a positive, it becomes a negative. It just reverses the sign of that number. Little math. I'm going to take right x, and it's just going to be the value from the right x-axis, no change. Okay, left y and right x. We're going to take these values, and then coincidentally, the motors can be adjusted to a power level from -1 to +1. -1 being full power backwards, +1 being full power forwards. Since our motors are already configured to run forward or backward, if I set them to full power forwards, my robot should go forward. So what I do is I'll make two more variables, double left power, double right power, and then left power is equal to left y, right power, sorry, I got to watch the capitalization. See what I did? Left y needs a capital Y. And then right power equals right y. So it's not right y, left y. That same joystick controls both motors. And next I'm going to take those power values and actually put them on the motors themselves. So left dot set power, left power. And then right dot set power, right power. Okay? Easy. So over and over again, it's going to read the values on the joystick, and it's going to set the motors to those power levels, and then adjust as you adjust the joystick. Here we're going to just test what we've done so far before we finish the code with turning and the use of the claw. So to test this so far, here's what we do. Let me make sure the phones are active and connected properly. Okay, and then, so I've got the phone here, and I'm going to show you what this does as I build the code. To build the code, you're going to use this little wrench right here that says build everything. So you click that, and it starts building. All right, we're going to try building one more time just to make sure that everything built okay. So I'll click on the wrench again. Okay, and it said build succeeded, so that's helpful. So when I pull down, so the right triangle on the phone screen is for driver controlled modes, and the left one is for autonomous modes. If I pull down the right triangle, I should see the program I just wrote, Gamepad Drive. And now I've got it open. I also can see I've got a little gamepad icon up there that shows user 1. If you don't see that gamepad icon, just make sure your gamepad's connected, and you may need to hit Start and A at the same time to activate this gamepad and set it as gamepad 1. Start and A. Next, I've got the software loaded. I'll hit init. Okay, after you've hit init, your servo is going to go to its initial position. So check your robot and make sure the servo is where you want it to be. I wanted mine to be pointing straight up, and it is, so that's helpful. Next, you can hit play, and you can try to drive your robot. I'll show you what that looks like when I test it.